In this question, we are given values of potential at various points along a line MN. So how do we find the electric field at x equals to 0.4 meter? Some people, right, may tend to use this formula, so they see that V is equals to KQ over R and E is equals to KQ over R square. They may be inclined, right, to straight away take the value of V divided by the value of X. Okay, unfortunately, right, this method will not work because this region of space, right, has an E field, but you do not know whether this E field, right, is created by just one point charge or not. Both of these formula, right, applies for only point charge. So if you want to use this method, right, of just taking the value of V divided by the R, it can only apply, right, mathematically. Okay, it's a mathematical coincidence, okay, for point charge. Yeah, so this method is out. Now, this region of space, right, have this nonlinear variation of V against X. So the correct way, right, is actually to use the formula E equals to minus dV dr. However, right, we can't plot out this graph. We wouldn't know what is the exact gradient to the graph at point 4. Instead, right, we will use the idea, right, that perhaps we can use the neighboring points, okay, because we know the values. So this is for 0.35, or no 0.35, it's 0.3, and this is for 0.5, okay, and then, right, find out what is the change in V, and here the change in X. So we take the gradient of these two, so you have 2.1 minus 1.5 divided by 0.5 minus 0.3, so that gives you 0.6, 0.2, so that will give you 3. Okay, and what is the direction? Well, since, right, the potential goals become more negative, means, right, it's pointing from high potential to low potential as it goes in the positive X direction, so it will be towards N.